Alright, welcome back, class. I want to point out one more thing that I did not have printed on this piece of paper. Sometimes we need to solve an equation. Let's say we are going to solve this thing that looks like this. 3x equals 93. I do not know. So look, how are we going to find this? Well, look, if this is 3 multiplied by mystery number, and it becomes 93, we can probably reverse this. We can backwards reverse engineer it. We divide both sides by 3. Why does this work? Because you can take an equation. The equation, this sign, this says that these things are equal. They are balanced. They're the same amount of stuff. If I take the same amounts and I divide them by 3, they're still the same amounts. They're smaller, but they're equal to each other still. So this is okay. So what does happen here? 3 divided by 3 is a big 1. 1 times x is just x. 93 divided by 3. 31. Look, this is called an equation with only one thing to do. You see? 31 was 93 divided by 3. What if it was like this? I say 17 minus x equals 24. Now you might look at this and think, this is rather strange. I start with 17, I subtract, and it gets bigger. That does not seem right. Let's not worry about that. Let's simply say, look, we want something that looks like this. X equals whatever. I want this to be x all by itself, isolated, like it is in Siberian Gulag. So we look at this and we say, let's subtract 17 from here. I don't like having 17 on the same side as x. Subtract 17, subtract 17. If you do the same thing to both sides, it is balanced. Okay, we have negative x equals 24 minus 17. What is this? Well, that is going to be 4 and 3, because I am comparing that to 20. You see, it is, well, perhaps you see my point. I do not know. You find out how this works. You subtract. You maybe use calculator if you need to. I'm pretty sure this is 7. Because 3 and 4. Okay. If negative x equals 7, multiply by negative 1 on both sides. What does this do? It makes it turn into x equals negative 7. There's your number. You found it. If you subtracted negative 7, of course it's getting bigger. That's what happens when you subtract a negative. So you see, these are examples of solving equations with only one or maybe sort of two things to do. If you have a multiplication, divide on both sides. If you have a number you want to make go away, and it is not multiplying, it is just sort of you subtract things later, then subtract it away. Let's try one last one. What if I had something that said x divided by 7 equals 2? Well, I want x to be all by itself. I will multiply both sides by 7. 7 times this, 7 times that. Oh, look, this looks too big. It's like an x. Scribble it out. 7 times x divided by 7. Well, I can say this is, look at this. This is like 7 divided by 7. 7 divided by 7. It does nothing. It just goes back to x. X, 2 times 7, 14. You'll check. Now, how do we check our answer? The way we check our answer is, we'll take this over here. We take the number, and we take the original thing that we had. This is the original thing. And we write it down, except instead of x, we put the number. 14 divided by 7. Is this true? 14 divided by 7 is 2. Yes, this is true. Therefore, we found the right answer. If we had been wrong, this number would be something else, and it would be incorrect, and we would say, oh, we must go back and correct our mistake for the glory of the Republic. All right, this is a little example of solving some equations. Best of luck with your studies.